Okay, this is the beginning of Unit 6. So we just got off the toughest unit in honors math analysis, and I promised you it would get easier, and it is. This I try to teach a little bit more common sense approach, a more visual approach than a mathematical approach, but I just want you to understand the concepts. We're doing conic sections. So when you take a cone and you slice from that cone and you get these two-dimensional shapes, which are conic sections. So the first one we're going to study is parabolas. And parabolas you did in a little bit in Algebra 1 and Algebra 2, and they're conic sections. It's a quadratic equation is what represents a parabola. So there's some important characteristics, and this is going to be taught differently to you than how it was taught in Algebra 1 and Algebra 2. The vertex is the point that's a relative maximum or a minimum point. So here's two different types of parabolas. This is the vertex right here. This is a minimum. And this is the vertex here, which is a maximum. And that works when the parabola goes up or down. One thing you've not seen yet is one that goes side to side. So we'll look at that in a minute. But the other way to look at this in a calculus perspective is that when the function is changing, this from decreasing and it starts increasing, that point is a max or is a minimum. This function is increasing and then it changes right here to decreasing, so that is a maximum. And the vertex is a point, so you have to list it as an xy, and it has to have parentheses around it. The focus is something new for you. The focus is going to be a point inside of this parabola. So imagine you have a satellite dish, and excuse my artwork. Here's your satellite dish, and you've got this point right there. What that is that's the focus point. All the sound waves that are coming in are going to bounce off the side and hit directly towards that focus point. Everything, no matter where it hits, is going to go back towards that focus point. So that's what a focus point is. It's always along the axis of symmetry. The axis of symmetry cuts this in half. So the focus is new. And the distance from the vertex to this focus is called P. From the vertex to the focus, this distance is P. The directrix is a line outside of the parabola, and it's dashed because it's not part of the parabola, it's just kind of a guidance. So it's always perpendicular to the axis of symmetry, and it's equidistant, or the vertex is equidistant from the focus in the directrix. So this, well, I've worded that incorrectly, but what I'm trying to say is this distance from the vertex to the focus is P, the distance from the vertex to the directrix is P. And I'll do an example to show you. So there are formulas that go with this. You don't have to memorize them. I typically don't use the formulas, but you're welcome to if you want to. I'd give them to you. When we're talking about a parabola that opens up or down, you're going to have it in the form x minus h squared equals 4p and then y minus k. P, once again, is a distance from the vertex to the focus or from the vertex to the directrix. The vertex is hk. Here's the formula for the focus and the directrix and the axis of symmetry. But I think it's going to be better if I just go ahead and do an example. So when you're graphing these at home, you need to graph it either on graph paper or draw the coordinate plane. So I'm going to give you this example. The example I have is x minus 2 squared equals 12, y plus 1. Since this 12 is positive, it's going to be a parabola that opens up. If that 12 were negative, it would go down. So the first thing I want to recognize is my vertex. My vertex is the point 2, -1. So I'm going to sketch a coordinate plane, and I'm going to plot that point 2, -1. I know that this opens up, so I'm just going to kind of draw the little sketch there. I'm going to come back and get rid of that in a little bit. That's just a visual for me. So the next thing I look at is my focus. Since 4p equals 12, p is going to equal 3. So I know from here, I've got to go up 3. That's why I drew that, because I know that the focus has got to be inside here. So I'm going to go up 3 points. 1, 2, 3. And notice I'm marking on the XY axis. There's my focus right there. I'm going to get rid of this now, because it's not accurate. I just wanted to show you what I'm visualizing. My directrix is the opposite direction of my focus. So if I went 3 up, I'm going to go 3 down. And it's going to be a horizontal line here. So this horizontal line is y equals -4. My axis of symmetry, and I don't worry about that so much in this course, but it was a big part of Algebra 1 and Algebra 2, is just this vertical line that goes here, so it'd be x equals 2. Then the hardest part for most students is picking points. There's an easy way to do it, and there's more difficult ways to do it. In this case, I'm just going to pick, when I'm looking at this, I know this goes up here. I know it's going to go through somewhere where y equals 0, or maybe something where x equals 0. So I'm just going to use 0 for x. And solve it for y. So my x value is 0. So -2 squared is 4. I'm going to divide by 12, and I get 4 twelfths is 1/3. Subtract 1, I get y equals -2/3. So I would have that point 0, -2/3, which is about there. Since it's symmetrical over this axis of symmetry, I'm just going to, it's 2 away from the axis this way, so I'm going to go 2 away from the axis this way. And it looks like that. And I could pick any point, that's just one of them I picked. Okay. New to you this time is if there's a horizontal axis of symmetry. Now this is different. This means the parabola is going to be facing right or left. It's not just doing this to it. There's more to it than that. So now we've got the equations in the form y minus k squared equals 4p times x minus h. And it's still this distance is p, either direction. The distance vertex to the directrix is p, vertex to the directrix is p. So I'll go through an example on this one. The example I have is y minus 3 squared equals -4 x minus 6. So I'm first going to get my vertex. And be careful, vertex is hk. H is 6, k is 3. Then because this is negative, the parabola is going to be going sideways like that. So I know that my focus has got to be somewhere along this axis of symmetry. And I have to move back 1. So 4p equals -4. So P equals -1. So if I come back 1, this is going to be my focus right here. So my focus is the point 5, 3. My directrix, since I moved 1 this direction to get the focus, I have to go 1 in this direction to get my directrix. And that's the vertical line, x equals 7. Axis of symmetry is going to be y equals 6. It's a horizontal line. And then I have to pick a point. I'm going to pick a 0 for y this time, because I know it's going in this direction. It's got to go through 0 at some point. So I'm going to do 0 minus 3 squared equals -4x minus 6. So 9 equals -4x minus 6. Divide by -4, I get -4. -9/4 equals x minus 6. Add 6, I get x is equal to 3.75. So I'm going to plot the point. I'm going to put 0 for y, plot 3.75 for the x. So 1, 2, 3.75 goes here. I'm going to reflect it. I went 3 down, so I have to go 3. I went 3 away from the axis of symmetry. I've got to go 3 the opposite direction. It looks like that.